Okay, the second question that I chose for my presentation was question G, and it asks, one of your students, Claudia, asks, why do statisticians use three different types of averages, mean, median, and mode? I think the mean alone would be good enough to summarize data. Do you agree? Why or why not? My response to this would be that I disagree, because when you're looking at statistics, you have to look at your data entries of your data set, and also you have to take into account the context of the problem. So let's take a look at what I mean by this. Again, I would start out with some definitions to make sure that the student had some understanding. And so I took these definitions from the textbook I use with my high school statistics class. It's a high school statistics class, but I would say that this is more on the college end of a textbook written by it's Elementary Statistics Picturing the World, 5th edition, written by Ron Larson and Betsy Farber. And it defines a measure of central tendency as being the value that represents a typical or central entry of the data set. The three most commonly used measures of central tendency are mean, median, and mode. So I know some textbooks define mean, median, and mode all as being averages, but in the high school we think of them more as defining them as measures of central tendency. That leads us to the definition of mean. And this textbook defines mean of a data set as being the sum of the data entries divided by the number of entries. And in high school, and even me as a math teacher, whether right or wrong, I traditionally think of the mean as being the average of the data. The median of a data set is the value that lies in the middle of the data set when the data is ordered. The median measures the center of the ordered data set by dividing it into two equal parts. If the data set has an odd number of entries, the median is the middle data entry. And if the data set has an even number of entries, the median is the mean or the average of the two middle data entries. Our textbook also defines mode of a data set as being the entry that occurs with the greatest frequency. The data can have one mode, more than one mode, or no mode. So to further explain these with my student, I would take a look at a data set. And here I have the ages of students enrolled in a college class. I'm not going to read them off to you, but there are 19 entries. And when we add them up to find the mean, we get 410 divided by 19, which comes out to be about 21.6. The median of this data set, since there are 19 entries, we do have a middle entry, 9 before it, 9 after it. And so our middle data entry would be the 10th entry, or 21 in this case. So the median is 21, and the mode in this data set would be 20. Now, if we're looking for which measurement of central tendency would be most appropriate, I would say that because the mean is 21.6 and the median is 21, that they're fairly close to each other, so they both would be very good representatives of this data set. However, on the mode being 20, that would not be very good because 20 is the lowest data entry of the set, so it's really not a measure of the center. Next, what I would do would be to introduce an outlier. So here again we have the ages of students enrolled in a college class, but now we have a student that is 65 years old. And an outlier is defined as a data entry that is far removed from the other entries of the data set, and 65 in this case is pretty far removed from 20 to 24. So to find the mean, we would add these up, which adds up to be 475, and since there are now 20 entries, we would divide by 20 and get 23.8. Our median, since we have an even number of entries now, you can see that we can divide them into groups of 10, and when we take the average of the middle two numbers, 21 plus 22 divided by 2 gives us 21.5, and our mode once again is 20. If we look at our original problem, our median is slightly different than our first set of data without the 65 in it. I believe our first median was 21, and this is now 21.5. So the outlier did have a little bit of an impact on that, but not as great as the mean. the outlier has a far greater impact on the mean than any other measure of central tendency. It actually pulled, I think it was 21.6 with our first data set. Now it's been pulled toward the 65, so it's greater than the center, which would not be the best representation of this data set. And mode, once again, we have that problem that the mode occurs at the lowest data entry, so it's not a very good representation of the center. Here's a visual describing that situation where we have our outlier. You can see this huge gap between these ages, so 65 is definitely an outlier. And where in the first data set, median and mean were very close to one another, 21 and 21.6, that is not the case here. The mean was pulled toward the outlier, and mode is on the very end, so it's not very representative of the center. Median would be the best representative of this data. When you gather data, you can graph it in histograms. You take your frequency distribution and graph it in histograms, and when you do that, you get different shaped distributions. And from those distributions, you can take a look at how it impacts mean, median, and mode. The first type of distribution we would have might be symmetric. And symmetric distributions occur when you have a vertical line that can be drawn through the middle of the graph of the distribution, and the resulting halves are approximately mirror images of one another. Uniform frequency distributions occur when all entries or classes in the distribution have equal or approximately equal frequencies. It's important to note here that a uniform distribution is also symmetric. And you can have skewed distributions, and skewed distributions occur if the tail of the graph elongates more to one side than the other. A distribution is skewed left, or negatively skewed, if its tail extends to the left, and a distribution is skewed right, or positively skewed, if its tail extends to the right. Again, these definitions were taken from my high school statistics textbook. Here's a visual of each of those distributions. And you can see in the first one, we have a symmetric distribution. And this happens to be a perfectly symmetric distribution, so you can see that the mean, median, and mode occur at the very center of the data. And in this case, they would all be equal to one another, and all three of them would be a very good representation of the center of the data. Usually, you won't get perfectly shaped symmetric distributions, but you can have something that's approximately symmetrically shaped, and in that case the mean, median, and mode will still be good representatives because they'll be close in value to one another. Here we have a uniform distribution, and you can see mean and median are perfectly in the middle of this. If it weren't perfectly uniform but close, these values, the mean and median, would be close in values. We do not have a mode here because there are multiple modes. They all occur at the same frequency. This distribution is skewed left. You can see that the tail extends or elongates to the left. And when you have a distribution that's skewed left, what happens is the mean is pulled slightly away from the center toward the tail, and the mode will occur to the right of the median because that has to be higher or with greatest frequency to give you the shape of the distribution. So the median probably would be the best representation of something that's skewed left, and also something that's skewed right, because again the mean would be pulled slightly toward the tail and the mode would be to the left of the median. So the median would probably be the best representation, although they're very close in both of these cases. From our Math 5170 textbook that we use, the mathematics that every secondary school math teacher needs to know, I took a quote from there saying that the mean, median, and mode are called measures of central tendency and can play an essential role in real-life decision making. Not only is it important for students to know the meanings of these terms, but that they understand when it is most appropriate for each use, or for each one. For example, mean is useful when reporting things like the average price of a movie in a certain city. Mode might be useful for department stores buyers who need to know which dress size sells best. And medians are useful when one wants to get an idea of the incomes of people living in a certain neighborhood. So this basically states that not only is it important to look at the data, but you also have to look at the context of the problem situation to determine mean, median, or mode, which one best represents or summarizes the data. I have some sample data sets. Here we have the responses of 1,000 adults that were asked the type of corrective lenses they wore. And the question is, what measure of central tendency would be most appropriate? This data is at the nominal level, and so mean and median would be inappropriate. You can't even calculate mean and median. So in this data set, mode would be the best representation. So again, we're looking at the context of the problem. Here we have the cholesterol levels of a sample of 8 female employees. And again, we're looking at the data, and you can see that 275 is an outlier. And so when they ask what measure of central tendency would be most appropriate here, it would have to be median, because there is no mode, and you have an outlier which you know has an impact on the mean. To follow up with my students, I might give them another data set. And in this example, I have a data set for the number of sick days used by 57 employees. And I might ask them what shape is the frequency distribution. Now they could graph it out, but just by looking at the data, they should be able to tell that this would be skewed right, because my highest bars in my histogram would be on the left, and they'd slowly tail out or elongate to the right. And in this case, which measure of central tendency is most appropriate and summative of the data set? Again, they could calculate them out, but knowing that the mode occurs at 10, because there are 15 10s in this data set, it would be not appropriate to summarize this data because it occurs at the end. It's the lowest value. And because we do have an outlier of 42, that would impact the mean. So probably in this data set, the median would be most appropriate. I might also ask the students what other statistical measures are important in analyzing data, and hopefully they would say things like the range and standard deviation, and there's all different sorts. The point here being is that when you look at data, you really have to look at the big picture. The standards all come from the SID, the standards for the Common Core. We want to be able to represent data with plots and the real number line. Histograms is where I made this connection. We want to use statistics appropriate to the shape of the data distribution to compare center, mean, and median, and the spread of the two or more different data sets. And we want to interpret differences in shape, center, and spread in the context of the data sets, accounting for possible effects of extreme data points like outliers. The standards, again, I have 4 of them. I want them to be able to make sense of problems and persevere in solving them. So basically, I want them to be able to understand the problem and come up with a way to attack it. I want them to reason abstractly and quantitatively. Basically, I want them to make sense of quantities and their relationships, which they would have to do with mean, median, and mode. I want them to attend to precision, which means to me communicate precisely and solve mathematics with exactness. And I also want them to construct viable arguments and critique the reasoning of others. And again, this is just being able to talk about the math and use the mathematical language. And that concludes my presentation. Thank you for viewing.